Hello and welcome to Bow's Floor Tiling Solutions for the Modern Build CPD. My name's Allan, Garland and I'm the Specifications Manager for the Southwest. As this CPD is pre-recorded, we can't take questions during the seminar as we normally would, so please find my details on this slide. If you have any questions or would you like to speak about any live projects, please feel free to call or email. Bow has a proud history. We were founded in 1962 by the tile manufacturers that constituted the British Ceramic Tile Council. As tiles materials were changing and there were no specific products or guidance for fitting tiles, the industry was starting to experience installation failures. To ensure tiles could be used successfully and grow as an industry in the UK, the council formed a specialist materials company to develop high quality products for tiling installations and provide a comprehensive technical advisory service for the industry. Bow was formed for the industry, by the industry, and it's a value intrinsic to all we do today. We have a number of different teams here at Bow who will be able to aid you at each different stage of the project. The specification team, for example, can deliver any of our 8 RIBA-approved CPDs in practice and also help advise which products to specify. We could even write that M40 or M20 specification for you. Our task team, or technical advisory service team, who are based at our head office in Stoke, are on hand during office hours for market leading technical advice. Now this is all backed up by our technical and training teams who are available for on-site technical advice, as well as systems training for contractors who may have not used the system previously, and things like moisture tests on newly laid screeds. In today's seminar we're going to look at the general design considerations for tiling installations, tiling calcium sulphate screeds, heated floors and also sheets and boards. We'll then run through a quick summary and a couple of key installations. In this section of the CPD we'll be looking at general design considerations. Successfully specifying and installing a tiled wall or floor relies on identifying all of the key elements of the installation. These can include substrate, prep, environment and tile type. We'll discuss each of these in more detail during the next few slides. Careful consideration should be given to the substrate to which the tiles are to be bonded, together with the nature of any surface preparation required. The base must be suitable for the surface conditions to which it will be exposed. Adequate surface preparation of the substrate is of course important. Now BS 5385 states that local variations in level for a nominally flat floor should be that when checked with a 2 metre straight edge with 3 mm feet at each end, the straight edge should not be obstructed by the tiles and no gap should be greater than 6 mm. Now, if we're talking about drying times, for example, an anhydrite screed will take longer to dry than the traditional sand and cement screed. Now, the anhydrite screed is moisture sensitive and can break down if tiled too early. This is normally caused by excessive moisture being trapped underneath the tiles and then saturating the screed. The surface must also be stable and rigid, and in case of floors, be capable of taking a dead load together with any traffic imposed on it without excessive movement or deflection. The maximum weight limit for tiling to a particular wall background must also be established, allowing 3 to 4 kilos within the maximum weight limit per metre squared for the tile adhesive and grout. Now, dimensionally stable for changing moisture conditions. This is normally based upon sheets and boards. Now, if we take sheets and boards, they must be capable of remaining dimensionally stable whilst in service due to changing moisture conditions. Where appropriate, additional protection must be provided by the application of a suitable waterproofing tanking system. If the substrate to be tiled is not flat and even, any undulations will be reflected in the tile finish. BS 5385-3 2014 recommends that surface regularity of SR1 when fixing tiles using a tile adhesive. No gap underneath a 2 metre straight edge greater than 3 mm when placed anywhere on the floor. If we talk about tanking, looking at a wet room or a shower, we need to protect the substrate. This is for a number of different things. It can protect the integrity of the building fabric and also protect the room from mould and unwanted smells. Priming. If the surface of the substrate is porous, then this could affect the success of the adhesion of the tiles, so it's always worth priming those substrates. Uncoupling. Now this may be required because of the variation in lateral movement between the tile and the substrates. check the substrates for the ability to crack. So onto the environment. Is it a commercial or an industrial area? What other stresses will the tiles be exposed to? Is it a dry or wet environment? Moisture loading, quantities of water. Are we expecting excessive quantities of water? Traffic load. What type of static and dynamic loading is expected? Will there be hard-rimmed or pneumatic wheel traffic as well as foot traffic? Abrasion resistance. Now, what type of damage is the traffic going to cause? Is the floor subject to pressure washing, for example? Exposure to chemicals. What are the cleaning regime requirements? Is there any chemical usage? Are there any hygiene requirements? Is it a commercial kitchen, for example? There are now thousands of different designs of tiles to choose from. When installing tiles, if they're installed correctly using the right types of materials and specifications, they can be easy to install, hard-wearing and durable. We put a 25-year guarantee on all of our specifications, for example. This allows us to give you the confidence that if they're installed correctly to the right specification, they will be hard-wearing, durable, easy to maintain and have lower life costs than some other finishes. Ceramic tiles can either have a porous body, which is greater than 10% water absorption, a vitrified body, which is typically between 0.5% and 10% water absorption, or a fully vitrified or porcelain tile, which would have a very low porosity. This is 0.5% water absorption, or less. Natural stone covers a wide spectrum of materials from the very dense to porous and translucent. Resin agglomerate is a mixture of resin and natural stone or aggregate. Mosaic sheets. Mosaic sheets can have a number of different types and shapes of material. There could be a mix between glass, natural stone, porcelain, sometimes even metal or wood. So we have to look at these on a case-by-case basis. Glass, they are non-porous and we need to check the backing of that glass to make sure that we can create a suitable bond. First and foremost, safety and use. This should take into account the floor tile slip resistance both in dry and wet conditions, the solidity of the tile finish, i.e. are the tiles fully bedded in the correct tile adhesive. Now we need to look at the correct cleaning methods. If we specify an incorrect cleaning method, this could hinder the tile slip resistance in the long term. Movement in the substrate. When we look at the movement in the substrate, we need to make sure we don't have excessive deflection, thermal movement or drying shrinkage. Also, the correct placement of movement joints could aid with the reduction of cracking in the tile finish. Environmental factors, as we discussed on previous slides, we are going to have a heavy traffic loading, and what's this going to do to the tiled finish? Also, are we tiling in an area like a workshop where we have the possibility of heavy objects being dropped? This could cause major impact damage. We're now going to move on to looking at tile adhesives and grouts. The correct selection of materials. Tile adhesive classification and standards. We have three categories of tile adhesives: cement-based, dispersion and reaction resin. Cement-based comes in a bag of powder and is mixed up on site. Dispersion comes in a tub which is water-based and ready mixed, ready for use. A reaction resin is normally a 2 or 3 part product with a resin and a hardener. Moving on to the classifications, we have 1, which is a normal adhesive, 2, which is an improved adhesive. This meets the requirements for additional characteristics. Then we have a lettered system. So F is a fast setting adhesive, normally cementitious only, and that achieves 0.5 newtons per millimetre squared within 6 hours. T, which is non-slip, that's normally used on walls. And then E, which is an extended open time, which is over 30 minutes. This is for cementitious and dispersion adhesives only. The first three are not tested for in accordance with the EN 12004 requirements, but are important to the end user and assist in providing an adhesive which is easy to mix and apply with a good working time. This allows for adjustment of pre-bonded tiles within a given time. BS EN 12004-2 has a test to measure for transverse deformation of tile adhesives. This gives us S1, which is deformable, and S2, which is highly deformable. Grout classifications and standards. In this section we have cementitious and reaction resin. Cementitious is normally, again, a bag of powder, and reaction resin is normally a 2 or 3 part product which you mix together, which is either a resin, a hardener and a colour, or a resin with a hardener and colour mixed together. The cementitious grout has two categories, one which is a basic grout, two which is an improved or polymer modified grout. The lettering system gives us W on the cementitious side, which is reduced water absorption, and A, which is high abrasion resistance. The main difference between a cementitious grout and a reaction resin grout is that reaction resin grouts are more often waterproof. Calcium sulphate screeds. A calcium sulphate screed is a screed containing anhydrous calcium sulphate as a binder. This converts to calcium sulphate dihydride gypsum when water is added. The chemical process completes within 3 and 7 days. The remaining moisture dries by evaporation. Now this can take considerable time depending on the amount of water and the thickness of the screed. The moisture should be tested prior to tiling. The latent should be removed correctly and in full, and the heated screed should be commissioned prior to tiling. BS 5385 states that a calcium sulphate or anhydrite screed should not be tiled onto directly. The latent should be removed by mechanical means, and the screed should then be primed prior to tiling. Priming will help prevent the formation of a tringite between the screed and the tile adhesive. As well as the advantages listed on this slide, an anhydrite screed can be quite quick to install. As it's delivered to site pre-mixed and pumped in liquid form, the installer can normally cover hundreds of meters in a day. The disadvantages of an anhydrite screed are that they have a high water content and they take longer to dry. These prolonged drying times could elongate a project and have a high cost of labour. They are water sensitive once fully cured and not recommended for use in wet or external applications. They require a low moisture content prior to tiling. Sometimes these levels need to be below 0.5% on the water by weight scale. We also have to consider the extended preparation. A calcium sulphate screed needs to have the latents removed mechanically and also be primed or sealed prior to tiling. These time delays can be expensive, and project costs can escalate if other trades cannot gain access to site. Existing anhydrite screeds can look similar to a traditional sand and cement screed. We need to take all measures to identify what type of screed it is, whether it be a sand and cement screed or an anhydrite screed. If we're not 100% sure the type of screed, I would suggest treating that screed as an anhydrite screed. That way we can make sure we won't get any adverse reactions. We also need to mechanically remove the latents that forms on top of an anhydrite screed. This should then be cleaned and vacuumed away. Also, we will then need to prime to help adhesion and protect against site contamination. If there's underfloor heating, we need to ensure that that is commissioned before the tiles are laid. The correct drying out of an anhydrite screed is incredibly important. The floor should have a moisture content of no more than 75% of residual humidity or 0.5 on the water by weight scale. We use the carbide method for testing. This is an on-site test that measures the moisture within about 15 minutes. It is, however, a destructive test, so perhaps the use of this on an underfloor heated screed might not be the best option. Forced drying the screed might also be possible. You'd need to ventilate the room and apply external heat or use industrial dehumidifiers. The commissioning of the underfloor heating after 15 days or so should also help the screed to dry a bit quicker. As you can see from this pie chart, a 50mm deep anhydrite screed will take a minimum of 60 days to dry prior to tiling. This can be elongated by adverse weather conditions or colder climates. As I've mentioned in the previous slides, we have a training and technical team here at BAL. The training and technical team can come out to site and test the moisture content of any of the screeds. We normally use the carbide method of testing, which is destructive, so this might not be the best system to use when dealing with an anhydrite screed or a sand and cement screed with incorporated wet underfloor heating. Tiling to heated screeds. Different types of underfloor heating systems can include a traditional water-fed system, which is normally piped and usually found in solid floors. Electrical systems, which normally work using lower temperatures and can help reduce floor heights. Some advantages to these systems are there are no visible heat emitters, meaning fewer radiators around the home, more space, and that helps create an open plan living area, even spread of heat, and fewer hot spots and hot locations. This generates a gentle, controllable heat, meaning it's more controllable, especially in individual zones. And then, potentially, it has lower running costs when used in conjunction with renewable energies, for example. A thermal expansion can cause differential movement between the floor covering installed and the background. This could lead to a number of different failures if it's not managed correctly. The coefficient of thermal expansion describes how the size of an object changes with the change in temperature. Specifically, it measures the fractional change in size per degree change in temperature. As you can see from the table on this slide, different tile types and substrates change in size differently. It is this difference that we need to manage to prevent costly failures. The factors to accommodate are the coefficient of thermal expansion, how much is the floor tiling expanding and contracting versus the subfloor, trying to minimise thermal and shrinkage movement stresses, correct placement of movement joints, and the choice of adhesive and grouts. We need to know and understand the effects of underfloor heating on different tile types. Resin agglomerate, for example, will expand and contract a lot more than a porcelain tile. Has the underfloor heating been commissioned? If not, then the initial expansion could cause cracking and costly failures in the long term. We also need to consider the environmental aspect. Is the system going to be running from a conventional heating system or a renewable system like a ground source heat pump or an air source heat pump? Movement joints will also need to be considered. To correctly specify a tiling installation used with underfloor heating, we first must make sure that the tile is stable at changes in temperature. Is that tile suitable? A resin agglomerate tile, for example, has a very high coefficient. Uncoupling matting. Now, in most situations where tiles and stone are installed, the consideration of an uncoupling mat is at the forefront of specifiers' minds. We need to use highly polymer modified cementitious grouts and adhesives. And also, when tiling with natural stone, we need to make sure we're using the right colour, so a rapid setting white product must be used. Movement joints must be used and installed correctly, in line with BS 5385 Part 3. Specifying suitable and trusted adhesives and grouts certainly helps accommodate the thermal movement. This and the next slide show the basic build-up of two types of heated floor. This is a typical underfloor heating system on a screed with a tiling installation above. The specification in terms of adhesives and grouts calls for a minimum C2 tile adhesive with a minimum CG2 grout. Highly polymer modified products, especially ones with rubber crumb technology, offer a brilliant flexibility and deformability to accommodate considerable movement and vibration. In this image, we show the use of an uncoupling mat. This could have been incorporated due to the size or type of tile used. This is the example of an under-tile heating to a tongue and groove timber floor. Typically, under-tile heating is a comfort or ambience-based type of heating, whereas underfloor heating is often used as a primary source of heating. For natural stone, introduction of an uncoupling system will also offer some additional protection against movement and stress cracking of the grout joints and the tile finish. Again, the specification in terms of adhesive and grouts call for a minimum C2 tile adhesive and a minimum CG2 grout. Highly polymer modified products, especially ones with rubber crumb technology, are recommended, together with a polymer modified floor leveler in this scenario. The commissioning of the underfloor heating should be carried out prior to any tiling. It should be increased by 5 degrees per day and also to the maximum operating temperature of the system. Maintain that temperature for a minimum of 1 week and then gradually reduce it by 5 degrees per day to 15 to 20 degrees. We would suggest consulting the British standards and also talking to the heating manufacturer to make sure all procedures are being followed. Requirements for tiling to sheets and boards, including timber. Here are some examples of typical boards you find being tiled to. Tiling to sheets and boards on the floor has always been difficult due mainly to the stability of the material and the dependency on the structural support to help stability. With the need for reduced build-ups, strength and rigidity is often sacrificed for thickness. Tiles are installed to be as a sheet of glass, i.e. rigid. Backgrounds which move and deform when in contact with heat and moisture will affect those tiles. The risk of cracking and debonding is a lot higher in these instances. As you can see from this table, the use of timber as a substrate in frequently wet areas, i.e. a wet room or a communal shower is unsuitable. It's unsuitable as well in most occasionally wet areas, plywood and softwood being the exception, but normally this has to be protected either with a tile backing board or a tanking system. In dry areas you can still use plywood, softwood floorboards or chipboard. This normally has to be overboarded to aid with rigidity. Tile backer boards, on the other hand, are suitable in all of these areas and should be considered for use over timber products every time. Please take a moment to read the information on this slide. Now, overlaid cement boards should be no less than 10 mm thick, and you should check the priming and sealing information of individual board requirements prior to installation. Here we have a number of solutions for tiling onto sheets and boards. Rubber crumb, for example, incorporates elastomeric adhesives. The elastomeric nature of a rubber crumb adhesive will allow for the difference in movement between a substrate and a tile. This can prevent costly cracking and failures in the long term. We'd now like to show you a few projects. Huddersfield Leisure Centre is a 12,500 square metre, £36 million leisure centre development in the heart of West Yorkshire. It's a good example of differing environments and challenges that we had to consider. It features a range of top sporting and leisure facilities, including a 25-metre competition pool, 20-metre training pool with a movable floor, and a family leisure pool with interactive water features, water flume and sidewinder. The new centre was designed to meet the client's brief for a multi-purpose sporting and leisure facility for the local community, which complements the existing street pattern and contributes to the regeneration of the town and surrounding region. The project featured more than 10,000 square metres of tiling in the main changing rooms, upstairs changing rooms, pool surround, leisure pool and main swimming pools. This calls for numerous preparation products such as screeds, renders, primers and bonders, as well as a number of different tile adhesives that were utilised based on the environment, substrate, tile type and installation need. The stunning £45 million redevelopment of Tate Britain was an award-winning example of tiling in leisure. The transformation included the Millbank project, creating new spaces within the national home to 500 years of British art. Stonework specialists completed 2 packages in the Grade 2 listed building's southeastern quadrant on staircases and flooring, involving both new build and restoration work. As a major addition to the museum's former layout, a large opening through the floor of the main entrance rotunda allowed a new staircase to be inserted. A further 2,000 metres squared of flooring included a stunning geometric design that extends through the lower level of the museum, the canteen, public areas and lower rotunda. The flooring at the top of the grand staircase has a complicated fleur-de-lis pattern that echoes the design of the staircase balustrade. In addition, 500 square metres of agglomerate skirting, dados and reveals were installed. A further 800 square metres of terrazzo flooring on the principal and upper levels and the marble mosaic floor in the entrance hall were also cleaned and repaired. Specialist product selection was key to use across the range of different tile types and to ensure ease of installation and the highest quality results of aesthetics to last a lifetime. Thank you for your time, and if you do have any questions or would like to discuss a live project, please do not hesitate to get in touch.